For the differential equation, dy dx is equal to x, y is equal to 3 when x equals 2. Estimate the value of y when x equals 3 using a step length h of 0.5. Check by solving the equation and computing y when x equals 3. Okay, so the information here gives us our x0, y0. That's going to be equal to 2, 3. So we're going to evaluate dy dx at 2, 3. And since dy dx is just x, that is going to be 2. Then our delta y is going to be dy dx evaluated at 2, 3 multiplied by h, which is 2 times 0.5, giving us 1. That means that our next point, x1, y1, is 2 plus h is 2.5, and 3 plus 1 is 4. And so the next step is to evaluate dy dx at 2.5, 4. So that gives us, since dy dx is just x, 2.5. Then delta y would be dy dx now evaluated at 2.5, 4, which is 2.5 times h, which is 0.5, giving us 1.25. And that gives us the x2, y2, and that will be 3 and 5.25. So that's given us our answer when x is 3, y is 5.25. And that's our estimate using Euler's method. So we now want to check by solving the equation, and that would give us y is equal to x squared over 2 plus a constant. But we know that y is 3 when x is 2. So 3 is going to be 4 divided by 2, which is 2, plus c gives us c is equal to 1. And so y is equal to x squared over 2 plus 1. And then y of 3, when x is equal to 3, is going to be 4.5 plus 1, which is 5.5. So you can see by Euler's method we got 5.25. Here we got 5.5. So there is a slight difference. But of course, if we'd used many more steps, taking h down to, I don't know, 0.001 or something, we would have got a much closer approximation. And we can try that using technology. We can see in our E activities that we have two for Euler's method. I tend to like this one here, where we use the series or the sequence generator. That's the one, the sequence generator. So the A's are the X's. So if we do what I just suggested, which is do a 0.001 or something, and the A0 would be our initial X, and so our initial X here was 2. And then the B's, the delta Y part is this part here. So for our one, that part is going to be 0.001, which is the H, times AN. which we'll find in here. And that's an just because this is dy dx equals x. And the b naught is 3. Okay, then we're going to generate the sequence, which is here. And we haven't got enough to get across to x equals 3. We're going to need to do a lot more steps there. So we can change the number of steps. That's not the correct one, it's this one here. And let's take that up to 1,000. And then go here and regenerate. And we can see at 1,000 we've got x equals 3. And this is 5.4995. If we click on it, we get it more accurately normally. But here it is exactly 5.4995, which you can see is very close to the 5.5 exact figure. And of course, you can make those steps much, much smaller than I did it even there.